Hey, geometry students, get ready for it. This one's going to be a toughie. All right, we need to be able to find the distance from a point, like point P here, to a line. Now, when I say the distance between a point and a line, what I mean is the closest straight line distance between a point and a line. I'm not referring to distance PA, even though technically that is a distance between a point and a line. Anytime I say, even if I don't say the perpendicular or straight line distance, what I mean is the shortest distance between a point and a line. In this lesson, we're going to learn how to calculate that distance. Now, this lesson puts a lot of things together. We are going to be using the distance formula. We are going to be using what we learned about perpendicular lines compared to other lines. Okay, so we're going to be able to find the equation of line PB, for instance, if we know the equation for line AB. So that's that thing where we have to find a line perpendicular to a line that passes through a given point. We know how to do that. And then we're also going to have to be able to solve systems of two equations with two unknowns. And that we're going to have to reach all the way back to algebra 4. I'm going to share some theorems to get started here, but I'm just going to make sure you understand, like, the theorems are not the important part of this lesson. They are, I mean, they're important, but they're not like the important part of this lesson. What's important in this lesson is that you're able to do the calculations, and that's where you want to probably really make sure you're paying attention and taking notes, especially the last question, which is going to have so many steps. Be ready. All right. First, let's point out this theorem. Theorem 42.1 states that through a line and a point not on the line, there exists exactly one perpendicular line to the given line. Hey, that's kind of nice for us, though. So if we know the equation of line AB, and we're trying to find the distance between point P and line AB, the first thing we're going to need to do is find a perpendicular line that passes through point P. And it's helpful to know that there's just one of them. There's just one perpendicular line that passes through point P. So I should be able to find that exact line. All right, the perpendicular segment from a point to a line is the shortest segment from the point to the line. So what I'm trying to do, this indicates that the important point for me to find on line AB is B, the point on line AB that the perpendicular that passes through point P also passes through on the line. Okay, so really what I'm looking for is a perpendicular line to line AB, and I need to, that passes through point P, and I also need to figure out what point B is. Some more theorems. I have two more. The perpendicular segment from a point to a plane is the shortest segment from the point to the plane. What theorem 42.3 says is, even though in this lesson we're talking about lines, technically I could also do this same thing with planes if I want to start thinking in 3 dimensions. And then if two lines are parallel, all points on one line are equidistant from the other line. And remember, when we talk about points being equidistant from a line, we're talking about the straight line distance from that point to the other line. So perpendicular lines or parallel lines are made up of an infinite number of points. If I isolate one point and say, okay, how close is this to the other line? I'm just looking for the straight line distance that's going to get me to the other line in the shortest distance. All right, so for this next part, we're going to be using GeoGebra. And we're going to be entering some equations into GeoGebra. I would expect that for ones like A and B, you're going to use graph paper. You're going to see for ones like C, D, and E, those ones are going to take a little bit more effort. They can't even be done on graph paper. You're going to have to use abstractly what you know from algebra and from geometry to solve for those ones. But A and B, let's start with the easy ones. So if I give you a line like y equals 6 or x equals 9, immediately your brain should be like, wait, y equals 6, that is a horizontal line at y equals 6. X equals 9 is a vertical line at x equals 9. And ones like these are going to be really easy. So let's take a look at y equals 6. What's the easiest way to find the distance between this point and this line? Well, let's do some counting. I could see if I zoom in just a little that this one's at -5, okay? And I'm just going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I count straight up from the point to the line, I traverse a distance of 11, and that should be my answer because the perpendicular line between this horizontal line and this point has to be vertical. So I'm just counting straight up on my XY coordinate because the Y coordinates go straight up. So let's see if 11 is the correct answer here. Yes, it is. Now, what if instead I had the line x equals 9? Same point, but now we're at x equals 9. Well, I'm going to do the exact same thing. I'm just going to count, but this time I'm going to count horizontally. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, again, maybe there's better ways to figure that out. I could have done 9 minus -3, but 12 is my answer. And the point is, those are really easy to find because you're basically just counting or using another mathematical means to traverse that horizontal or perfectly vertical distance on the graph. But now what about one like this? This is one I had graphed before, 2x and 6, 2. Well, this one looks deceptively easy. So y equals 2x. There we go. I'm going to make sure that we have the whole equation written out here. Y equals 2x. And then my point is 6, 2. So I'm going to go ahead and plug in the point 6, 2. And when I look at this, okay, hold on. 1, 2, 3, 4, 5, right? It's 5 away. Well, actually, that line, that horizontal, is not perfectly perpendicular compared to this line. I need to find the perpendicular intersection between this point and this line. Maybe it's at 2, 4. It looks like it might be there, but I don't know. I don't know for sure. The right way to do this, the way that you have to do this, is using a combination of what you know about geometry and algebra. Let's go. Okay, so here's how we're going to do letter C. First thing we need to do is write an equation that is perpendicular to our original equation, y equals 2x, but passes through the point 6, 2. Now, we know how to do this. We start with y equals, I'm going to put this in slope-intercept form. The slope has to be the negative reciprocal of 2, because this one has a slope of 2. My perpendicular has the negative reciprocal slope, x plus b. Okay, I've got it in y-intercept form. I don't know what b is, but I do have a point that it passes through. It passes through 6, 2. So I'm going to plug in 2 for y equals -1/2 times 6 for x plus b. Well, -1/2 times 6 is -3. I'm going to add 3 to both sides. I get b equals 5. Okay, so I now have an equation of the perpendicular line that passes through the point 6, 2. My equation is y equals -1/2 x plus 5. But I also have this equation, y equals 2x. All right, so what am I going to do? I need to find an xy that satisfies both of these equations. So basically, I've been given the equation of this line. Okay, this is not the actual line from the problem, but it's a similar thing. I'm given this line. I've been given a point not on the line. I found the equation of the perpendicular. Now I have to find this point B. And then to find the distance, I'm going to need to use the distance formula between this point and this point. Sounds like a lot of work, and it is. But it's the way to do these. So here's what I'm going to do. I have two equations in slope-intercept form. That means that both of them are equal to y by itself on one side. I'm going to substitute, instead of y in the first equation, I'm going to substitute 2x. So it's going to look like this. 2x equals -1/2 x plus 5. I'm going to add 1/2 x to both sides. That gives me 2.5 x equals 5. 2.5 is the same as, so 5/2 x equals 5. And then I need to divide both sides by 5/2. Dividing by 5/2 is the same as multiplying by 2/5. So actually what I'm going to do, let's just write it out that way. Let's say that I'm multiplying this side by 2/5, and then I'm multiplying this side by 2/5. What's 5 times 2/5? It's just 2. So I'm going to get x equals 2. And if x equals 2, I'm going to plug that into the second equation. If x equals 2, then y equals 4. Now I found the point of intersection, this point right here, between my perpendicular line and my original line is 2, 4. All right, you'd hope we were done, but we're not. We need to find the distance between the points 2, 4 and 6, 2. And to do that, I'm going to use the distance formula. Y2 minus, oh, I'm sorry, it's a y. Oh man, I'm struggling with distance formula. Okay, so d equals the square root of, so I'm just going to say d squared for right now, and we'll have to take the square root at the end. Equals y2 minus y1 squared over x plus x2 minus x1 squared. That's what it is. So at the end, you could do it x's first. It doesn't really matter. Let's do the x's first. So 6 minus 2 is 4. It's going to be 4 squared. Okay, took me a second to remember this because I don't use it every single day. And then 2 minus 4 is negative 2. I can square negative 2 and I get 4. But I'm just going to write negative 2 squared for right now. This is going to be a pretty straightforward one. So d squared equals 16 plus 4. So we're going to have a square root of 20 situation here. D squared, d equals the square root of 20, because 4 squared is 16, negative 2 squared is 4. Get 4.47. Let's see if that's the right answer for this one. 4.47? Yes.